Hi everyone, welcome to our Sprint 4 review. So I have with me Vinay, Shivanja and Arnav, and we have finished 5 days of our Sprint 4, and I'm just here to share the progress till now. So let me just share my screen. So as you can see, this is our Taiga board till now, and I was working on applying multi-classification to existing models, which I have finished, and now I have to work on hyperparameter tuning and play around with the metrics. I'm simultaneously also logging in the results in the document. So this is the current status of our Taiga board. As you can see, everyone has finished one task each and are working on their second tasks. And let me just show you the code for ANN using TensorFlow. So, so we have just used uh, TensorFlow and two hidden layers for the model, and uh, this is the data pre-processing part where null columns are removed, and Arnav has applied Pearson correlation to extract the highly relevant, highly correlated features, and he has used normalization to find the min and max scaling as well. And here we have applied all the layers for ANN. As you can see, we have applied uh, three dense layers followed by another dense layer. And this is the result that we are getting. And yeah, that's it from my side. Shivanja, would you like to continue?
Yes. So I'll share my screen first. Is it visible?
Yeah, it's visible.
Okay, so currently I'm trying to enhance the frameworks that we're using. So this is a CNN model that I have defined here that I have been training the data set on. And the way we are trying to enhance this model is by using a technique called as quantization. So what quantization does is that every parameter every neural network has thousands and hundreds of parameters. Those are the weights and biases of each network and each connection. So quantization is a method by which we reduce the size of those weights. So reduced size means that we have enhanced the model because reducing the size increases the speed and reduces the memory. So in a GPU with reduced memory, we can parallelize the model and train the model on multiple cores, which makes the inference and training time what faster than what was faster than compared to the non-quantized time. So basically, what quantization does is it takes the weight, and if it's let's say a 16-bit float or a 32-bit float, it reduces it down to an 8-bit integer or a 4-bit integer. So there is some loss of accuracy in that we have observed, but the loss in accuracy is not that significant, but the gain in speed and inference time is quite significant. So it's a trade-off between those two things. So that's one of the things that I have worked on so far. And other than that, I'm also playing around with the hyperparameters. So I've created like different neural networks with different hidden layers and like different configurations of hidden layers and different versions of ReLU activation function. And I'm logging all the observations uh, of this experiment so that we can find the right values of hidden layers that will give us the best accuracy. So that's what I've been working on. Vinay, would you like to go next?
Yeah, I can go next. Let me share my screen. You see my screen?
Yes.
Okay, so I implemented the GAN-based model using the CAD boost classifier. Um, so then I'm also working on this is a binary classification. I'm also working on creating a GAN based with the multi-classification. But for this demo, I'm going to show the CAD boost one again. Uh, um, so the general idea of the GAN base is generator and the discriminator. Generator creates the synthetic data, which is the fake data. And what discriminator does it has to check whether its job is to check whether the data created by generator, whether it's a fake or uh, real data. So the job of the generator is to create a fake data, and discriminator is to discriminate between the fake and the real data. More the accuracy, the more your discriminator is working accurately. So I ran this. It didn't take much of a time. Training time is only 360 seconds around. Prediction time is 0.40. Every time this is changing. One case I was getting prediction time is 0.16 as well, and the accuracy is pretty good. It's around 99.97. Uh, so that means the accuracy is 99, means the discriminator is able to discriminate between the real and the synthetic data, and the model is performing well. Uh, and the GAN base is giving pretty good numbers. So we also discussed this with our sponsor, and he said that this is the comparable performance. So we can add this. So I'm still exploring into this how I can change and improve the accuracy of that. As you can see, I'm using EPOS as 100, batch size is like a 64, and my training and test split is 80-20%. Um, I'm dropping some columns which are not relevant, which are which have a lot of missing values, as I was doing before. And yeah, that's pretty much. I'm using the Adam optimizer, and loss function is binary cross entropy. So I'm gonna play around with it more and see whether I can improve the performance of this model. But for this demo, this is pretty much, and this is what we have shown to our sponsor, and he's pretty impressed with it. That's pretty much on my side. Adit, over to you.
Yeah, so this was pretty much about our sprint review for this sprint. Thank you, everyone.
Okay. Thank you,
Thank you.
guys.